split this up into two sections. So we'll do the first part, and then you'll do some questions, and then we'll come back and do the second part. The first part's really straightforward and should only take a very short amount of time to do some of those questions, okay? So we've come across limits when we were doing differentiation by first principles. So now it's actually, when we were doing that by first principles, we're coming across the limit as h approaches 0. And so when we had our equation with h in it, we put h equals 0, but this limit means as it approaches 0. So it's like you're putting in a 0.0001. Does that make sense? So you can't actually put 0 in, but it's like something so close to 0. So it gives us our approximation. So we're going to be doing limits here. So we've got some just general formulas that we're going to write down. Then we'll show how to actually do them. So it may look a little bit complicated at first. So a lot of jargon, but it simplifies down very easily. Does that make sense? So now, as I said, this looks sort of a bit complicated, lots of terminology, but it boils down to something quite simple. However, why we have to write this down is next year, and maybe on exam questions, you're going to see terminology like this, and you're going to have to decipher it. But it comes down to simple stuff. Does that make sense? And you'll see what I mean here. So this limit as x approaches a, so our a is 2. So that's what that's our value of a, okay? We've got f of x plus g of x. So this is like our f of x term, and this is our g of x term. Does that make sense? So this doesn't look complicated. This is just saying that this one and this one, this is like our f of x, this is like our g of x. So that means that I can take the limit of that, and then I can take the limit of that. So that's all it's saying. I can take that part and put it to just that. I can take that part and put it to that. So that to that, that to that. That's all that rule is saying. It looks more complicated than what it is. So when we were doing our limits as h approaches 0 in our first principles, we subbed in h equals 0, even though it wasn't really 0. That's what the limit means. So it means that I would be subbing in something like 2.00001. So not 2, but a number so close to 2 that we can assume that we're putting 2 into it. Does that make sense? So all I'm doing now is I'm subbing 2 into that. So 2 squared is 4, 8. So as I said, this looks complicated, but it boils down to something very simple. But you need to know this terminology. Does that make sense? So this is saying if I put the limit into this equation, then it's going to get really close to 14. It's a limit. So it's approximating it to 14. So that's the idea of this idea of a limit. It's not really 2 that we're putting in, but we're approximating it to 2, so it's going to get really close to 14.
So on the framework, okay, could you just write equals 14 and not have to write anything else?
Yeah, that's it. So this is what, but the question might have some sort of this at the front of it. May not. It can be as simple as this, but you know how there's straightforward questions. Your straightforward questions might have that. And then you might have, find the limit of f of x to, and then it'll just look a bit more complicated. But it really does boil down to just something very simple. Yep. So this one is like this one here. This one's our f of x. This is our g of x. This is our a. So it's basically this one here. So it means that I can take the limit of that and then the limit of that. So if I'm taking the limit, I'm subbing in 1 into that. So I get 1 plus 1 over 1. 2 over 1 equals 2. Nothing hard, is it? But there's got to be a trick to it. You're going to come across ones that aren't so straightforward. So if we follow the same pattern on this one, what am I going to do? I sub in 2 into that, I get 2 squared, minus 2 minus 6, 2 minus 2. Where's my problem?
0 is undefined.
Yeah, I get 0 on the bottom. As soon as you get a 0 on the bottom, it becomes undefined. So we've got to do something else. So this is where... So I'm just going to write it back up the top here. So we've got to do something first. Any idea of what we might be able to do first?
Factorisation.
Factorisation. So I can factorise this. So we've got to do factorisation. So I'm going to have... Anyone tell me what that factors down to?
Okay, take 2 and
So this is where all those factorisation skills come in. So I factorise that. Now what can I do? Now I can cancel it out. So I can cancel out that, cancel out that. Now I can sub the 2 in. So I get 2 plus 3 equals 5. So as soon as you start subbing things in and you get a 0 as a denominator, you've got to go, uh-oh, go back and look, and you should be able to factorise the top and cancel down. Okay? So as soon as you get into this situation, go back, factorise the top.
But wouldn't it be unconfused why it's positive 3?
Okay, so I've got x squared. If I do my cross multiplication, x and x gives me my x squared. Then I've got to look at factors of 6, which is 3 and 2. But when I add these up, I've got to get minus 1x. So if I do that, that gives me my 3x. If I do that, that gives me my 2x. To get 1x, or negative 1x, that one's got to be negative, doesn't it?
Yeah.
So then, hang on. Sorry, that's a minus 6.
Oh, okay. That's why.
Minus 6. So one of those has got to be a minus. It's got to be the minus 2 there.
Yeah, see, that's why I'm confused. I thought it had to be negative 3.
That should be a plus. There we go. Plus, plus, plus. There we go. That fixes it up.
That makes them both work.
Yep. So that's got to be a minus 2. That's got to be... We've got got to get it to be a +1 there. So that's got to be your minus. There we go. Yep.
I'm with you now.
With us now? I'll write that down. So, we've got to make sure that we can cancel this down. Because we don't want a 0 on the bottom.
Wait, but if you factorise like the normal one, then it would be a different answer.
Okay?
Like the easy one.
You can't factorise that, but there's no 0 on the bottom.
Alright.
This one's fine because there's no 0 on the bottom. You can't factorise that down.
If you factorised one, that
as soon as you get a 0 on the bottom, then you've got to look at factorisation. If there's no 0 on the bottom, then it just works. Yep. So if there's a 0 on the bottom, that's when you've got to start working onto it. So you should be able to start doing some of those questions now. Okay?